Hello. So, we will be discussing on routing protocols. We will be rather continuing our discussion on routing protocol in our course of computer networks and internet protocols. So, as we discussed that routing is a layer 3 phenomena which connects networks, right, and the device is at least layer 3 enabled. So, and also we know that every router maintains a routing table or sometimes called forwarding tables, which is sort of a lookup table by which any packet coming to that router look at that table and then get forwarded to the next hop. And this as the overall internet is dynamic, not maintained so to say with a single administrative authority. So, this routing table need to be updated so that the overall knowledge of the network, how need to be, where the paths are need to be is known to the things. Now, one beauty of the thing is that that this routing protocols which helps in updating these routing tables updates the tables individually. That means, router A or router X has his table X which is updated and independent of the other things, right. So, it is only concerned about this updating this table in such a way. So, it helps in providing the best possible route. So, that is the basic objective. So, the routing protocols which is employed or deployed is basically in every router is basically to update the table with other collateral informations. And also we have seen there is a concept of autonomous systems. That means, the whole internet is divided into several autonomous systems with a autonomous system identifier, where there are two type of things, one routing within the autonomous system and another across the autonomous system. So, in a sense we have intra domain routing and inter domain routing type of things. As we understand that whenever you have more administrative control and over a particular network and the resources, you have a better way of manageability. But when you have in a very large network, then you have to follow some sort of a what we say collaborative approach, right. Secondly, there can be lot of other issues which come into play. It is not only finding the shortest path or the optimal path. It may so happen that I need to look at some policies, like I can say that I want to forward this packet, but I do not want to travel through this network, right, or I must travel through this network, or these are the networks which are more friendly networks which my packet need to be travel, etc., right, other than other metric like congestion, list time, RTT and a lot of other things. I can have some sort of a policy defined on the particular while pushing the packet across the network, right. So, today we will see the basic concept or basic components of autonomous system and or AS, and the basic philosophy of the path vector routing, or which the popular routing protocol BGP employs, right. So, it is most of looking at the autonomous systems and the path vector routing is the thing, along with definitely the BGP will come into play. So, just to repeat the same picture. So, we have broadly two things, intra domain and inter domain, and this path vector is a inter domain routing. That means, across the domain or across the autonomous systems type of things. Now, what is a autonomous system? So, autonomous system or AS can be looked as a logical portion of a large IP network, right. So, it is a definitely there are physical router etc., but it is logically a large IP network, and an AS normally consists of an internet network within an organization. That means, it is somewhat under one administrative control or one administrative what we say policy, right. it is administered by a single management authority, and AS can connect to other autonomous systems managed by the same organization or public or private and so on and so forth, right. So, let us repeat. So, so what we are saying that this whole internet, I take a group of things which are logically maintained by a organization or a administrative authority, and it can, or it definitely it have to communicate with other autonomous systems which are maybe of the same organizations, maybe of other organizations, maybe public, maybe private and type of things, right. So, what in a sense what we have, like the figure shows, that we have several such autonomous systems across the things, and autonomous systems is identified by a unique number what we get from from the international regulatory or authority, and so that every autonomous system has a unified is a unique number to identify. Now, within the autonomous systems there are routing are done by through inter-domain, right, intra-domain, right, within the domain routing, and typically OSPF or RIP are the popular things to be routed. So, in this case we have, you see, we have 4 autonomous systems. There is a designated router called border router, autonomous border router, which keeps the informations of all the network within the autonomous systems. So, in other sense it gets updated by the OSPF or RIP protocol, inter-domain routing protocols, which updates the things, right. This in turns helps in this routers helps in finding the path between one autonomous system to another autonomous system. So, we try to emphasize there is a concept of path between one autonomous system to another in autonomous system. That means, when the packet is routed, it try to find out that in order to reach the destination, which are the ordered set of autonomous system need to be covered, right. And this gives us, we will see, this gives us lot of flexibility in policy based routing, right. I can say that I do not want to touch that autonomous system, or I want to go through this autonomous system, provided there are connectivities available and so on and so forth. Now, this autonomous systems goes on updating their information using these border routers, right. So, if we look at the routing protocols at the autonomous systems, as we have discussed. So, 2 sets of routing protocols are used to determine the routing paths within the AS. One is to determine the routing paths within the AS, others are used to interconnect a set of autonomous systems, right. So, one is within the AS, that means the routing which will be done within the AS. As we are saying, these autonomous systems individually are with one organization or one administrative control. That means, what sort of routing has to be done is based on that the total discretion of that particular organization, which may be influenced by the type of organization or type of traffic flow it is having, and nature of the organizations or nature of the network they want to envisage and type of things. It is nothing to do with the other autonomous systems. Only the autonomous system looks at the informations by these border routers, etc. And secondly, what we like to have, the others are the protocols which are used to interconnect a set of autonomous systems. So, I need a protocol which allows us to connect to the other autonomous systems. So, interior gateway protocol, IGPs, interior gateway protocols allows routers to exchange information within the AS, right. So, examples are Open Shortest Path First or OSPF, and routing information protocol or RIP. So, these are the popular protocols which we already we have seen. So, these are 2 popular protocol, one is based on distance vector, another is based on link state protocol, right. There is other set of protocols which are based on routing across the autonomous system, or what we say inter-domain routing, and those are exterior gateway protocol. So, allow exchange of summary information between the autonomous systems. The example, one best example is the border gateway protocol or BGP. So, that means the border router of every autonomous system have a summarized information of the whole autonomous systems. Now, this summarized information are being exchanged with the other border routers, right. So, based on this information, they exchange, they find out the path between the source which is generated from one autonomous system and destination which is at the other and some other autonomous systems, how the things will follow. So, there is a concept of area in autonomous systems. So, what we have seen, the internetworking is divided into several autonomous systems. Given a autonomous systems, it is divided into different areas. So, area is a collection of routers, network and host within an autonomous system. Each area has an area identification number or area ID, right. So, an AS can be divided into different areas. All network inside the area must be connected, right. So, all the network within the area should be connected. That means, area is a connected network scenario where there are routers, networks, hosts, etc. So, routers inside an area flood the area with routing information. So, what we see that the whole internetwork autonomous into different area, routers within the area basically share information or flood information inside that areas. So, so there is a special router called border area routers summarize the information about the areas and send it to other areas, right. So, there are border area routers. So, every router, every area often particular autonomous systems has a border area routers which summarize the information about that particular area. One of the area or sometimes referred to as area 0 is the backbone area. Special area inside autonomous system, all areas in AS must be connected to this backbone area. The backbone acts as a primary area, other as secondary. So, in an autonomous system, what we see that there is a area called backbone area, or at times the area with ID 0, which basically takes care or summarizes the information of the all the areas of the autonomous systems, and all areas must be connected to the backbone area, and backbone area acts as a primary area and other areas as secondary, right. Routers within the backbone area are called backbone routers. A backbone router can also be a area border router, right. So, as backbone is also area, so area border router can be a backbone router. So, this backbone router acts as a as the information hub for the whole autonomous system. This connecting to the backbone does not mean that the routers in the area cannot connect to the routers in the other area. For that matter, it also does not mean that a router in particular autonomous system cannot connect to a routers in the other autonomous system. It is more of a information summarization which comes into play, right. If I want to get information and try to find a routing path across or for the inter-domain routing, so from to whom I should consult, right. So, these are the custodians of information things, but that does not restrict that a particular area router to connect to a particular another area router of another area, or even the a router in a autonomous system, in area router of the autonomous system connected to another router of another autonomous system type of things, right. So, that is more of a network connectivity which we may not which we cannot dictate per se, right. So, those connectivities are there, but the overall summarization or custodian of informations we require this type of backbone routers. So, if we try to see, say there are area 1, area 2 and a backbone of area 0, and there are different routers. So, area border routers, and there are backbone routers. One router in this particular backbone is designated as AS boundary routers, right, which shares or informations based on the policy of the autonomous systems with the other autonomous systems, right. So, we have this sort of structure. So, there is, so just to repeat, there is a area 0 or backbone router, we have area 1, area 2 dot 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 area n, and there are area border routers which allows to connect to these backbone routers, and in the backbone area or area 0 there is a AS boundary router, designated router, which keeps the summarized information and share with the other autonomous systems based on the standard and the policy of the autonomous system, right. So, this is the overall structure wise, right. Now, if we look at that path vector routing, right. So, in path vector routing table contains destination address, next route and the path to reach the destination, right. Unlike if you look at OSPF and REAP or distance vector and link state, in this case we have the destination address, next router to be hit and the path to reach the destination. Now, this path is a ordered set or ordered list of autonomous systems that the packet need to travel through, right. So, the path is defined as a ordered set of routers or autonomous systems that the packet needs to travel through. The path vector messages, so there are different what need to say the different characteristics or different components of the things. One is path vector messages, AS routers that participant in the path vector advertise the reachability of the networks in their autonomous systems or ASs to the neighbor autonomous boundary routers using these messages, right. Two autonomous boundary routers connected to the same network are neighbors, right. So, it is if it is on the same network or it is connected by the networks, they are neighbor, and these path vector messages are the message which are exchanged between the things. So, as we see that there should be some format. Not only that, this your autonomous system, this boundary routers or border routers need to be updated by the OSPF or REAP, that means distance, either this your distance vector or link state protocol, again using some messaging, right. There should be a structure to do that by which it updates, right. So, each router that receives a path vector verifies the advertised path is in the agreement with the defined policy or not. So, once a router receives a path vector, it checks that whether it is a agreement with the defined policies, right. So, it is policy based routing, right, also supports policy based routing. That means, it says that whether in its policy it is allowed or not. Suppose it says that you cannot cross AS 13, right. If the path says that AS 13, that is not a feasible path for this or acceptable path based on the policy for this particular router. So, there is a problem because there is a issue of loop, right. If there are different autonomous systems, there are several autonomous systems, every autonomous system such boundary routers or backbone router boundary routers are updating the paths, that means a set of or a ordered set of AS numbers. Now, in doing so, it may so happen that there can generate a loop based on that the routing algorithms etc. type of things are following, like in BGP and type of things, it may end up in a loop. So, how to identify a loop? If there is a repetition of the AS, like if I gave AS1, AS2, AS6, AS9, AS12, AS13, again AS6, AS49 etc. So, there is a loop into the path. If there is a loop, it identifies and discard the thing. So, when a router receives a message, if there is a loop or if can identify the loop, it ignore the thing. There is a way of policy based routing or policy routing, as we are discussing. Policy routing can be implemented in path vector routing, that I can always say that with path, if say a particular AS need not to be crossed or need not to be in my path or for forwarding my particular packets of a AS, then it can check, and if it is there, it can discard that particular path. Also, when we talk about paths, so it comes with attributes, right? How do you, it is not only the AS along with the attributes. So, there are two broad attributes, one is the well known attributes. So, there are few attributes which are well known attributes, and there are few attributes which are optional attributes which can be followed or not, right. Well known attributes like I can have origin of that particular message and type of things, that can be a well known attribute. So, well known attributes should be recognized by the these routers, that is inter domain routers, right, popularly that, or in other sense that BGP routers. So, if we look at the well known attributes, some of the attributes are mandatory and some of the attributes are discretionary. So, this different set of attributes helps in defining that particular path, right. So, not only that, it may so happen that some of the attributes need to be updated when there is a update to the other routers, right, and those if some, so that means that is a mandatory to update that particular attributes to the next router. So, using this attribute, we can more finely define the paths along with the packet will move. So, one of the popular protocol or the protocol, you can say, there is a BGP protocol or border gateway protocol based on the path vector routing. Distance vector protocol not preferred as the inter AS routing, right. So, it is exterior routing protocols. So, that we distance vector or even link state protocols are not very popularized. So, it assumes all routers have a common distance metric to judge router routing preferences. That means, while we do a distance vector, I take care that whatever the cost or the distance metric we are using, this is agreed upon metric, everybody is doing like that. So, if routers have different meaning of a metric, it may not be possible to create a stable loop free things, right. So, in distance vector, the distance or cost, what we think that all are same. So, a given AS may have different priorities from another AS based on the metrics, gives no information about the AS that will be visited, right. So, it is no information about the AS, there is no summarized information about the AS. So, there is not preferred. Even in case of a link state protocol, there is different metric. Flooding is not realistic in such a large internetworking scenario. So, it will eat away a lot of bandwidth, and finally, the convergence will be a major problem. Every router, if it wants to keep a track of the whole network topology on its things, ideally fine, but it is not physically or even theoretically means practically feasible, right, because it is not possible to converge on the whole network and take a call based on the things. So, there will be huge traffic problem. Even the router may not be able to handle such a network and run a algorithms with its own resources to do that. So, this is also not realistic for practical implementation of in case of a inter-domain routing, right. In path vector, there is no such ideally metric. So, you have a sequence of paths which is looked into. So, information about which network can be reached by a given router or AS can to be crossed is the only thing, right. And it is somewhat differ from this distance vector algo by in the sense the path vector approach does not include distance or cost estimation, right. It is more of the path which sequentially is given, and based on the attributes and other, list all the A's visited to reach the destination network. So, it basically gives a ordered set of list. So, it is not ideally it goes on calculating the distance, etc., right. So, this makes more sense in a large internetworking scenario. And if we look at the BGP or this which is based on path vector, there are several messaging. One is open, one is update, keep alive, notification. So, open message is sends to whenever you want to send a message or send a communication with the other BGP protocol. There is important for update, like means that BGP also can basically update, in a sense, remove, create a already advertised some path, a particular router or border router can update the things, right. And in case of a keep alive is basically saying that the router is ready for receiving messages. So, it is sort of a beckoning, a keep alive type of messages, and there are, if there are some erroneous or sudden conditions which need to be alerted, is using the notification. So, messages are typically sent over TCP connection on port 179, function procedure, neighbor acquisition. So, when we do is a open message, acceptance through keep alive messages, neighbor reachability, periodic keep alive messages, network reachability using broadcast and update message, right. So, each router maintains a database network that can be reached, right, plus the preferred route to this particular network, right. So, it can have a policy of the things. So, that means using this 4 category of messages, BGP protocol tries or basically finds that the or in other sense update that routing table to find out the paths, right. So, that particular RFC does not include or address that how a router knows the address of another router and so on and so forth. It is up to the network administrator to have that type of things, that how the router information can be collected, that which are the how to get the router address and type of things. Now, if we look at that what we were discussing. So, if it is that router N1, the for network N1, a next router is R1 for this AS, and the path is AS to reach there is AS 14, AS 23, AS 67, right. So, this is this way it is defined. So, in order to reach N2, the next order is now do not try to directly match with this figure. So, the table is example of network reachability of the things, right. So, in order to reach N1, this next router is R1 and the path to be follows is 14, 23, 67. In order to reach N2, next router is R5 and the path is followed to be so and so forth and like this. So, what we see that by unlike other our link state or your distance vector, here the ordered set of AS or AS IDs are given. So, loop prevention in BGP checks the path before updating the database. If it is AS in the path, ignore the message, right. So, there will be loop if it is the same AS is there in the path. Policy routing, if the path consists of AS against the policy of the current AS, message is discarded, right. So, these are the messaging format while updating, right. It is saying that in order to N1 within the AS R1 and AS1 is there. So, router 2 gets that things, right, and router 2 when it is advertising that in order to reach N1 you next router will be R2 AS is AS2, next AS is AS1. So, that means from here anything goes to looking for N1, it knows that the next router will be R2, right, and it has to travel by AS2 and AS3. Similarly, here if you see anything goes to N1, it next router is R3 and it goes through AS3, AS2 and AS1, right. So, the path is defined in this way. And these are different formats of the BGP messages: open, keep alive, update and notification, so that it can exchange information across different AS. Similarly, for OSPF, which is within the border area network, which we have already discussed. So, that is within that particular within the AS. So, it uses IP and has a value of the IP header. If you remember, there is a 8-bit protocol field. Interior routing protocols, its domain is also an autonomous system. Special router, autonomous system, boundary routers, as we have discussed, backbone routers responsible for dissipated information across the AS in the current system, divides the AS into areas, and metric to be used it minimum delay or RTT, maximum throughput and so on and so forth. And for OSPF, which is based on link state advertisement, is there, and there are several messages. So, link state advertisement like router link, network link, summary link to the network, summary link to AS boundary router and external link. So, these are the different category of link in the LSAs. And similarly, LSA or OSPF, when it is within the router. So, summary link, it is summary link to the network. Similarly, for external link, it is a for the external network, and this is a summary link to the AS boundary routers, right. So, there are different summarization or information about the autonomous systems are being pumped into the things. And this is also that what are the different type of OSPF packets, and especially the link state update, we require the router link, network link, summary link to the network, summary link to AS boundary routers, which takes care of that summarization of the whole autonomous systems and share with the things, and external links. And this is the typical format of the OSPF packet. Similarly, we have link state advertisement or LSA summary that formats or the packet formats, that how it is how the different things, the summary link to network format, summary link to AS boundary, external link format. So, these are defined formats. What it tries to emphasize, so there is a standardized way of communication between with the messages, and it also helps in talking with several autonomous systems without any with standard messages without any hindrance. So, with this let us end our discussion today. In the next talk, we will discuss little more into this BGP protocol to see that how this BGP protocol works and how this overall routing is feasible. Thank you.